Alright, so everyone should have gotten the notes for our next unit. We're going to be looking at rational functions, very in depth actually. I know that we've seen these before, most likely last year in Algebra 2, where you've kind of had this graph that had asymptotes on it. Does that look familiar? At least I'm hoping it does. Okay, we're going to go over a bunch of different properties and characteristics that this particular type of function and graph has. Because unlike polynomials that we just exhaustively went over, okay, those roller coaster type graphs, this is clearly not that same type of shape. So we're going to take a look at this new type of function and kind of determine characteristics and properties that this one has. Now, when you put this in your notes, I think, and Hunter kind of noticed, this page 241 does not match up with the last page that we just did. So we are going to skip Unit 3 for now. We're going to try to come back to that towards the end of the year. Unit 3 is very short and it's not really related to the polynomials that we just finished and these rational functions that we're starting now. So I think it's going to be a little bit more beneficial for us to try to get that done at the end of the year because there are some more important things that I'd like to get done before those. Okay, so just in case you notice that the pages don't match up, that's the reason why. Okay, so rational functions, we've seen that word before when we did the polynomials. We had the rational root theorem where we took the factors of the constant term and divided those by the factors of the leading coefficient. So whenever we did that theorem, we were creating a fraction, okay, where we had those different possibilities for x-intercepts. So this word rational just means fraction, aka ratio, aka comparison. So all of the equations that we're going to pay close attention to in this unit are going to be fractions. For our first example here, we're going to take a look at g of x at the top. Notice how it's a fraction. We have some polynomial up top divided by some polynomial on the bottom. So just as kind of a review of characteristics that we've dealt with so far this year, I want to take a look at this polynomial that would generate this graph given to us, and can we identify these different properties based off the graph? Based off this picture, can we figure out where this function equals 0? Can you kind of pinpoint where on this graph we should be looking for? If a function equals 0, yeah. How'd you know it was -1? Mm-hmm. That's an x-intercept, okay? So if a function equals 0, you are on that x-axis. Can we figure out where this function is greater than 0? Good, Alex?
-∞ to -3, and then to -1.
Excuse the interruption. At this time, I need those students who were on the list for the biology keystones to report to the Audion. Again, biology keystones. Mr. Kleckner sent a list out this morning. Please send those students to the Audion. Thank you.
All right, Alex, can you continue? You said -∞ to -3.
And that'd be parentheses.
Okay.
Then it's parentheses -3 to -1, which is also parentheses.
Okay.
And then we have 1 in parentheses to +infinity.
All right. There's a lot going on there. That's perfect, actually. Okay, so let's kind of see, based off this graph, where these intervals show up. So if we want to go all the way to the left and then stop at -3, looks like we have this section right here. Alex, why'd you stop at -3? That was good.
Because there's an open circle.
There's an open circle. Okay, there's no graph there, meaning we cannot include it, so we have to skip over it. And then we're going to go from -3 to -1. Why did you stop at -1?
Because it's on the x-axis, so it's not above.
Okay, so greater than 0 from way back at the beginning of the year, that's indicative of above the x-axis, where we have positive y values. So we got to stop at -1 because that's where we said we are on the x-axis. And then we go from 1 to infinity. So we have an asymptote at 1, which is probably why you said, Alex, it'd be a parenthesis because we don't have a graph there. And notice how the rest of the graph that we have is above the x-axis. Okay, so we're going to read the graph from left to right, and for this particular question, we had to figure out where is it above. Let's try something similar for number 3. Okay, if we're less than 0, we want to be below the x-axis. Can we try to pinpoint that interval, or maybe there's more than one? Like the previous one, you want to keep going, Alex? Yeah.
-1 to 1.
Negative.
Parentheses.
There we go. Okay, so we start at -1, but we cannot include it because we're on the x-axis. And this section of graph ends at the x value of 1, but we cannot include that either because there's an asymptote there. Okay, there's no graph at that spot. I like it. Okay, so for 4 and 5, notice how they're very similar to the previous two, but the only difference is now we have a bar. So maybe we can include some of the points that we previously skipped over. Let's see where those might be. So if we are above the x-axis, we're going to have a similar interval to number 2. We just got to ask ourselves, can we include the -3 that we skipped over? Can we include the -1 that we skipped over? Can we include the +1 that we skipped over? Okay, so we got to go back to those ones and see if we can change them. Can we somehow put a bracket on -3? Are we able to include that spot? Yeah.
No.
No, because it's forever and always a hole. Okay, there's never a graph there. So this first -3 that we skipped over, we cannot include it. Let's go to -1. Can we include that spot that we previously skipped over? Yeah, because now that we equal 0, that means we can be on the x-axis. So this previous parenthesis we can change to a bracket. All right, and then the last value we skipped over was 1. Okay, some here at the asymptote. Since there's an asymptote there, there's no physical graph there, kind of similar to the hole, there's no way that we'll ever be able to include that because there's no physical point there to actually touch. So that's going to stay a parenthesis. So out of the 3 options, it looks like only one of them could have changed to a bracket. What about if we're less than or equal to 0? So definitely a smaller interval. Can we include either of those endpoints? Can we change a parenthesis to a bracket? Yeah?
You can change the parentheses before the -1 to a bracket.
Before the -1. Okay. So notice how the x-intercept was -1, and that's actually the only value that changed, because that's the point that we can either include or not include depending if we have a bar or not. The -3, which was the hole, and the 1, which was the vertical asymptote. Good morning. Anything for the office today? I think we're good. Thank you. Yep. Have a good day. So the hole in the vertical asymptote will never ever be able to include because there's no physical point there. So no matter what type of interval you're describing, it's forever and always going to be a parenthesis. It's just the x-intercept that has that capability of either being a parenthesis or a bracket, depending on the notation that we're trying to identify. So for these rational functions, we kind of have a lot of different things that can be going on here. Sometimes we can have an asymptote, sometimes we can have a hole, maybe we have one x-intercept, sometimes we'll get into maybe even 2 or 3 or 4, depending on the case, but we're going to start to dive into these a little bit more in this particular unit. So let's see if we can kind of pinpoint some other different properties or characteristics about this graph. Given the function, okay, the same one that they gave us at the top, find these function values. Do you guys think you can do that fairly quickly? If you plug in -3, see what you get. If you plug in 1, see what you get. Did you get 0 over 0 for negative 3? Yeah, that's a little weird, okay? And then 8 over 0 for 1?
Yeah.
Okay. Can we go a little further with these? Do we know what 0 divided by 0 is? Yeah?
Undefined.
It's undefined. Okay, some of you might have the inner thought to say that that's 1 because you see the same number being divided by itself, right? 8 divided by 8 is 1, 0 divided by 0 you might think is 1. But why is it undefined? Yeah?
Because you can't divide anything by 0.
You can't divide anything by 0. I don't care what's up top, okay? You can never ever divide by 0. So that result is going to be undefined. Same reasoning kind of here, where we have an undefined value. Now, they're both undefined, but the fact that this one was 0 over 0 and this one is a number over 0 is kind of hinting to us what's happening graphically. What was special about the x value of negative 3 in the graph? Yeah? It's where an open point was, okay? An open circle. And what does an open circle kind of look like? 0, right? We have 0 over 0. So whenever you plug in a number into a rational function and you get this result, 0 over 0, that's signifying that you have an open circle at that spot. Okay, we're just going to go ahead and call that a hole. Like a chunk of the graph is missing. You have a hole in the graph. What was going on at this spot of 1? Yeah.
It's the asymptote.
It's the vertical asymptote, okay? So no longer do we have 0 over 0. When we have a number over 0, graphically, we know we're going to have a vertical asymptote at that spot. So the fact that they're both undefined is telling us that something interesting is going on at those locations, but the actual number result is going to tell us even more. Okay, so 0 over 0 signifying a hole, number over 0 signifying a vertical asymptote. So what's nice is if we can somehow figure out what makes the bottom of the fraction 0, we automatically can find those kind of interesting characteristics on the graph. So using the graph, explain why your efforts had the outcomes that they did. We can say that the x values of negative 3 and 1 make the denominator equal 0. So there is no physical point on the graph. Okay? If there's no physical point, okay, that's some type of discontinuity. Okay, I'm bringing back a word that we kind of used earlier this year. You either have a hole, which we've seen. You could have a jump. That's not happening in this case. Remember, a jump is where the left and the right don't meet. Okay, they have two different heights. Or you could have this vertical asymptote. So if we can figure out what makes the bottom of a fraction 0, which we already know is a no-no in math, okay, we can't divide by 0, we're going to figure out where those kind of special characteristics are located. Now we're going to use these points to our advantage to kind of help us solve these rational functions, and we're going to get there in a little bit. One thing that we have to be careful of, though, is when we're going to solve rational functions, it's going to be definitely in our favor to factor to try to find these special spots, and maybe there are even some hidden ones that we have to bring into consideration as well. So if you take a look at this same function, okay, same rational function, can we factor it? We have two polynomials, two quadratics. Can we factor the top and factor the bottom? Let's maybe do the top. Can we think of two numbers that multiply to 3 but add to 4? Good, Alex? 3 and 1. What about the bottom? Two numbers that multiply to negative 3, add to 2. Yeah?
3 and negative 1.
3 and negative 1. Okay. So, notice how when we factored it, if we were to actually solve the bottom factors, wouldn't this be x equals negative 3 and x equals positive 1? Those were the same locations that we had up here where that hole and asymptote were happening. Okay, so those are the numbers that make the bottom 0. What about the numbers that make the top 0? Yeah?
Negative 1 and negative 3.
-1, -3. Okay. So when you're factoring, let's see if we can kind of figure out where we have a hole versus where we have an asymptote. Why do you think we have this hole at -3? What's happening with these factors that's going to give us a 0 over 0? Do you see it?
They're kind of like canceling out on both sides.
They can cancel out. Do you see how the number that makes the top 0 is the same number that also makes the bottom 0? So if the same number is going to make the top and bottom 0, notice how that's going to give us that 0 over 0 like we got algebraically. So without even plugging in a number or testing it, we can kind of get the same result by factoring. That's not the case, though, for this negative and positive 1. Okay, those aren't the same. We're going to pay much more attention, though, to this idea of canceling later on in this section, or even unit. Okay, but this is kind of a good intro into that. So if these are the numbers that either make the top 0 or the bottom 0, let's see if we can figure out these two questions here. Of these 4 possibilities, which one would make the overall fraction 0? When you have a fraction and it equals 0, what do you know about either the top or the bottom? Yeah?
It's going to be -1
Why -1?
because that's the only one that wouldn't make the bottom 0, so it'd still be defined.
If your fraction equals 0, you have 0 over, some, bless you, some number that obviously isn't 0, like 0 over 10, 0 over 100, 0 over -2. Okay, so if you want the overall fraction to be 0, you got to figure out what makes the top 0 but not the bottom. So looking at these 4 options, -1 makes the top 0, but we did not have -1 on the bottom. So maybe we'll write that little note. Top equals 0, but not bottom. How can we find the x values that make this fraction undefined? Yeah?
Can you just look at what makes the bottom 0, which is -3 and 1?
Yes. Okay, so if a fraction's undefined, we know the bottom is 0. I don't care what the top is. It could be positive, it could be negative, it could be 0, like we had here. As long as the bottom is 0, your fraction will be undefined. So these two numbers we'll go ahead and list here. Okay, bottom equals 0. What we're going to do is use these, in this case, 3 options. Even though we had 4 numbers, notice how -3 showed up twice. We're going to use these 3 numbers to help us solve polynomial functions. So instead of having a graph to help us figure out where are we below, where are we above, we're going to try to do this algebraically. And we've done it before this year. Okay, actually twice. Remember that sign chart method with the positives and the negatives? We're going to come back to that. Okay, we did it for absolute values, we did it for polynomials, and now we're going to do it for these rational functions. So let's go ahead and try this one on the back. Okay, it happens to be the same function. So we're going to have the same factors. They were x plus 3, x plus 1, and then x plus 3, x minus 1. What we're going to do is take those special numbers, what makes the top 0 but not the bottom, and then what makes the bottom 0. Okay, where's the function equal to 0, where is it undefined? We said on the previous page that was -1 from the top, and then -3 and +1 from the bottom. We're going to use those numbers to help us break up this number line, because we know these are some special spots where something is happening graphically. -1 was that x-intercept that makes the fraction 0, and then -3 and 1 were those undefined sections where we either have that hole or that asymptote. So we know something special is going on here. We want to kind of see what's happening in between those locations. All right, let's draw our number line. So in order, we'll have -3, -1, and 1. Are we familiar with how this works? Can we think back to how we've done this before? Where do we go from there? Once we have our number line set up? Yeah.
You like plug like everything in? Like,
What do you mean by everything?
I'm not sure.
That's fine. I know it's been some time. Go, Jordan.
You pick a point that's not like negative or negative 1.
All right, so you got to pick a point somewhere in between these. Okay, so pick any number you want from negative infinity to negative 3. Anything in there. What are we feeling today? Absolutely nothing. Okay, so we'll do negative 5. All right, I want you to take negative 5, and we're going to plug it in. You could do the original equation if you wanted to, but I think the factors might be a little quicker because they're a little less tedious. And we're only going to be looking at the signs. Do we have a positive result or a negative result? So if we do negative 5 plus 3, that's definitely negative. If we do negative 5 plus 1, that's definitely negative. Let's do the same thing for the bottom. Negative 5 plus 3, negative. Negative 5 minus 1, negative. So now that we have the individual signs, we're going to combine them together by either multiplying or dividing, whatever that is going on in this fraction, to get our overall sign for that interval. So on the top, if we have a negative divided by negative, negative times negative, that's positive. Negative times negative, that's positive. What about a positive divided by positive? That's overall positive, right? Okay, so we're going to do the same thing for each interval. You just have to pick a number that you feel comfortable plugging in. What about negative 2 for the next one? Okay, let's plug it in. Positive, negative, positive, negative. We'll get negative over negative. Negative divided by negative is positive. All right, maybe we'll try 0 for the next one. Positive, 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 negative. Positive over negative, negative. And then for the last interval, anything bigger than 1, so maybe 2. Positive, 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 positive over positive, positive. Coming back to us? Slightly? Okay, so now that we have our sign chart complete, we're going to use it to our advantage to answer kind of the original equation, or in this case, inequality at the top. So what we're trying to figure out is, where is this function, where would the graph of this function be less than 0? Can we think about graphically what we're trying to analyze here? If we're less than, or in this case, equal to 0? Yeah.
When something is on or below the x-axis.
On or below x-axis. Okay, now since this is a rational function, these 3 special numbers could be one of 3 things. Okay, we either have a whole, we have an asymptote, or we have an x-intercept. Okay, if negative 1 made the top 0 but not the bottom, that's an x-intercept. Okay, we know that's a physical point on our graph. If negative 3 makes the top and bottom 0, what's happening there? If we get 0 over 0, 0 looks like a pole. Okay, so we know there's no physical point there. And the number 1 only made the bottom 0. So this is telling us that we're going to have some number up top, but 0 on the bottom. That's going to be our vertical asymptote. So when it comes time to analyzing this sign chart, we have to be aware as to which of these three numbers we could possibly include and which ones we definitely can't. Okay? If we know that there's no physical point at a whole or a vertical asymptote, I want you to put a little X over those locations. That's telling us when we write our intervals, there's no way those can be a bracket, because there's no physical point there. Okay, the only possible bracket location we have could be at -1. So now that we have all this figured out, okay, positive, negative, and all that jazz, let's see if we can label where we are below or on the x-axis. So clearly, based off of our positive and negative locations, we're below here. But since we could be on the x-axis, we got to figure out if we need brackets or parentheses or kind of a mixture of the two. So can we think about, do I need a bracket and parenthesis before the negative? Do I need a bracket or parenthesis after this negative? What do you think?
You need a bracket and then a parentheses.
Why? That's perfect. Yeah.
Because -1 is on the
That's an x-intercept, so you can be on it. That means we can include it. Okay? And why was this one a parenthesis?
it's the vertical axis.
It's a vertical asymptote. There's no physical point there, so there's no way you can include that. Okay, so based off of this analysis, our overall interval would be bracket -1, comma 1 with a parenthesis. Now notice how we did all of that without a graph. Okay, just so we kind of get comfortable with this, I provided a graph at the bottom. So if we did actually want to double check where this function was below or on the x-axis, we could definitely kind of trace that interval. And notice how we start at -1 with an x-intercept, so we can include that, and we stop at +1 because of that vertical asymptote. So our result seems to check out based off the graph. We doing okay? All right, let's go ahead and try another one. Maybe we'll finish it, maybe we'll not, or we won't. We'll see where we can go from here, okay? Completely factor the rational function. Notice how it's a fraction, okay, so aka rational. It's already factored for us. So can we find those special locations that might be telling us something about the graph? Can we label the x values based off the factors? X equals... Let's see, we'd have -3 from the factor up top. We'd have +1 from the factor up top. And a -2 from the factor in the bottom. Okay, can we list, if these are special numbers, they're either a vertical asymptote, a hole, or an x-intercept. Okay, can we go through and label what each one of those is? It looks like -3 makes the top 0, but not the bottom. So if this is going to give you 0 over a number, what's going on at -3? Maybe we'll come back to it. If we plug in 1, yeah. That's an x-intercept, yep. The y value would be 0. Good. Okay, let's check out 1. 1 makes the top 0, but not the bottom. So that's another example of 0 over a number, whatever that number is. So this is another x-intercept. And then if we plug in -2, that's going to make the top a number, but the bottom 0, yeah?
Wouldn't that be a vertical asymptote?
That's a vertical asymptote. Okay, so it looks like we don't have any holes in this particular case. We didn't get 0 over 0 for any of those options. Okay, so we're going to take these special locations and use those to break up our number line. Do you guys think you can fill out the number line? Pick your numbers, positive or negative, see what you get. We might have to talk about the first one. Let's see. Okay, I picked -5, but if you pick something different within the interval, that's fine. you happen to get a negative value for all of those factors, but notice how the bottom factor is being squared. So we have to take that into consideration. We're squaring some negative number in this case. So in the top, negative times negative would be positive. What happens if you square a negative? Yeah,
Becomes positive.
that's going to become a positive as well, because it's technically a negative times a negative. So it looks like overall in this interval will be positive. Positive divided by positive. All right, go ahead and try some of the other ones. All right, I got positive, negative, negative, positive. Does that seem to check out? Okay, so now that we have our signs labeled, let's go ahead and see if we can include any of those X or these locations that we listed in our number line. So based off of what we said here, -3 and 1 are x-intercepts. So these ones have the possibility of being included depending on what the inequality is telling us. But since -2 is a vertical asymptote, we'll never ever be able to include that. Okay, that will forever and always be a parenthesis. It has to be. So looking at the inequality, less than or equal to 0, what are we trying to find based off the graph? Yeah?
What's below?
Below x-axis. All right, so we're looking for negatives and negatives. So we got to figure out, do we need bracket or parenthesis before and after each of those negatives? What do you think, Jordan?
You need parentheses on all of them.
On all of them. Okay, so this is an x-intercept. We cannot include it because that's on the x-axis and not below like we want. We have to skip over -2 because that's a vertical asymptote. There's no physical point there. So this first interval is all going to be parentheses. We'll start the next interval with another parenthesis because it's at -2. And then if 1 is another x-intercept, we have to skip it because it's on and not below like we want it to be. So bringing in the numbers, we'll have parenthesis -3 to -2 with a parenthesis. And then we have the other interval to consider. We'll go from -2 to 1 with a parenthesis. So without having a physical graph, we can identify where we are below the x-axis. Just to double check, let's check out the graph at the bottom. So this is the graph of the rational function. Notice how there's no hole on there because we said there shouldn't be anyway. None of those special numbers resulted in 0 over 0. So that's checking out. If we trace where we're below here and here, okay, we'd have to skip over -3 is on the x-axis. We have to skip over -2 because we have that vertical asymptote. And then we're going to skip over 1 because we're on the x-axis. And it seems to fit exactly what we said from the number line. You see how everything's clicking? It's connected? Okay. We're going to try a few more of those tomorrow, okay? I'm hoping the rational functions aren't too crazy for us, at least yet, because we're familiar with them, but we're doing a similar number line process that we have experience with. So I'm hoping we have a little bit of confidence.